Very often, we struggle to read the chilled water plant water flow diagram from control perspective. In this brief presentation, we will go through the main components of the chilled water system and water flow circuit for every loop. This is a central chiller plant with multiple chillers banks, heat exchangers, pumps, and associated piping. It consists of chilled water, CHW loop for cooling loads, blue lines in the diagram, condenser water, CW loop for heat rejection to the cooling towers, green lines, hot water loop, HHW for building heating loads, red lines, domestic hot water, DHW loop via a plate heat exchanger and hot water tank, black lines. Water comes from cooling towers at the top left on the diagram, passes through a condenser water strainer, filter. Distributed to chillers banks, CH1 to CH4, each chiller banks have 12 chiller modules. Each chiller bank has its dedicated isolation valves, strainers, and flow meters. Pumps, P1 and P2, circulate condenser water through the chiller's banks. After absorbing heat in the chiller condensers, CW goes back to the cooling towers for heat rejection. There are 4 chillers banks, CH1 to CH4, connected in parallel. Each produces chilled water that flows to the building load loop. Primary CHW pumps, P4 and P5, circulate water from chillers to the distribution loop. Each bank has its own DP sensor and a bypass valve, VCHW-DP. Pump VFD modulates based on bank's DP value, and to avoid deadheading or to ensure minimum flow for the module, bypass valve opens up or closes when required. The BMS operator chooses mode, cooling, heating, simultaneous. Each bank can operate in the assigned mode of operation. BMS opens. First, chiller bank condenser water flow valve. Secondly, chiller bank chilled water flow valve. Next, BMS starts associated pumps, and associated chiller bank modules start its operation. Based on the bank DP value, pump VFD ramps up or ramps down. If there is no flow, chiller bank master controller will send flow alarm to the BMS. Chiller banks are enabled when N1, return temperature on the banks is more than the chilled water set point and delta T between supply and return header. 2. Based on the delta T, chiller bank controller will enable the number of modules. 3. When delta T decrease, conversely, controller will reduce the number of the modules in the associated chiller bank. BMS will monitor the following points: chiller enable, disable, per bank. Pump VFD speed, status, runtime, priority, alarms. Flow valve positions, CW and CHW sides. Differential pressure sensors, primary and secondary. Chilled water temps, supply, return, decoupler. Delta T and load calculations. Individual chiller kilowatt per tonnage for efficiency monitoring.